Hello class, welcome to our lesson today. We're going to start on section 7.3, which deals with triangles. We're going to spend a few days on triangles, just covering the different aspects about triangles, their side lengths, determining what's a triangle, how to label them, and those types of situations. So let's go and get started with the first questions, which is just creating triangles given some information. Now the first question says that you want 4 centimeters on one side and 5 centimeters on the other. Now, if you have a ruler, you should be able to measure that out yourself. If you don't have a ruler, I would say be a little bit creative and at least get a good estimate. Okay, so for example, a centimeter should be about the width of your pinky finger. An inch should be about the width from knuckle to the edge of your thumb. That's a good way to look at an inch. We want to start thinking about conceptually the distance idea. But if you have a ruler, I would recommend using it. The important thing in this case is you may have a very different triangle than someone else when you draw it. Okay, because all that's needed here is a 4 centimeter and 5 centimeter side length. So notice I made 4 centimeters and 5 centimeters to be kind of like this and make an acute angle. There's no stipulation saying it couldn't be obtuse, so you could make it go the other way and then connect the third side. Obviously, the third side would be longer then, but you could still connect it and make a triangle that fits the given description. Remember, the 2 tick marks means inches. Okay, so 4 inches and 3.5 inches. Notice I didn't measure these 2 triangles, but at least I know that the inches one is larger. Now, it's probably not large enough comparatively to the centimeters one that I drew out. Okay, but remember, 4 inches on one side, 3.5 on another side, and there's no other stipulation there, so you can make the other sides whatever you would like, and then find the triangle based upon those descriptions. For the next 2 questions, these ones have to be more similar to each other if you look at yours versus another student's. When you have to draw a triangle given 2 angles, my suggestion is you draw a line segment on the bottom. So notice I just drew this line segment right here, okay, from this spot to this spot. Once you have that, what you want to do is use your protractor and draw 60 degrees and just draw a line and just keep it going for a while. And then from the other point, draw 75 degrees from the other side of the protractor and keep that line going for a while. And essentially where they meet up, that's where they're going to cross, and that will make your triangle. Now, depending on how long you made the bottom piece of this triangle, that would probably mean your triangle is a different size than another one's, but they should look very similar to each other in terms of their size. Now, maybe you did it sideways or something. If you rotated them all and made them look similar, that's probably what you're looking at when it comes to this situation. For the next one, I did the exact same thing. Start with my side length on the bottom here, this line segment. From this angle, I draw 40 degrees and going kind of this way. It should be an acute angle. The most common mistake is when you try to do 100 degrees, people have the angle going kind of towards the other one, and it makes it an acute angle. It's because when you read your protractor, you're reading it from the wrong measurement piece. So really work on making sure you know how to use your protractor to make a triangle with the given description. The next thing that we need to discuss is what makes a triangle work or not. So can the 3 lengths make a triangle? Now the easiest way to do this is to take 3 pieces of string or 3 pieces of wood or something, and just cut distances of 4, 6, and 7 centimeters and say, can you make a triangle? You just lay them out, and it's either going to be yes or no. So this first one is yes. Now we'll go through kind of in the next couple slides why it's yes. But what you'll notice here is that the 2 smaller sides add up to be larger than the largest side. So 7 is smaller than 10, 6 plus 4. Think about it. This is 7, and if you think about like a door kind of idea, here's 4 and here's 6, they collapse in. They're going to make that triangle. 2, 4, and 7 will not make a right triangle because the longest side, 7, if you take 2 and 4 and kind of smash them in towards the 7 to make the triangle, kind of like when you do like card stacking, you want to make sure that they stack. Well, these 2 and 4 aren't even going to be enough because 2 plus 4 is only 6, and you need 7. You need more than 7 to at least get some tilt to it and some height to it. And so this won't work because 2 and 4 are less than the longest side, 7. The next one, 2, 4, and 6 will not work. And the reason for that is if the longest one is 6, essentially you're folding 2 and 4 and they fold perfectly in on it. There's no depth to that, so it doesn't make a triangle. It's like a line and you lay another line on itself that's just in 2 pieces. So that one still doesn't work. Whereas 3, 5, and 7 will work because 3 and 5 make 8, and 8 is larger than the 7. And so the 5 and 3, when you collapse them down, will have some depth to it and some height, and then compared to the baseline of 7. What you want to do is compare the largest side with the other 2 sides. So here's a general rule of thumb. The sum of any 2 side lengths must be greater than the third side. I tend to always say, where's the largest side length? I look at the largest side length, look at the other two side lengths, add those two up. As long as they're larger than the third side, then it's going to work okay. The other thing about angles that you've probably heard before is that 3 angles of a triangle add up to 180 degrees. That's something that's going to be important when we start solving angles of triangles later on. This is just a review of direct variation because there's a few review questions at the end of your homework. Remember, direct variation means it's proportional. Proportional means it goes to 0, 0, and has a nice linear progression to it. Okay, so the first thing I would check, I know direct variation is difficult for a lot of students right now. It'll get better as time goes on. First thing I would check is, does it go through 0, 0? Because if it doesn't go through the origin, there's no hope of it being direct variation. So for the first one here on the left, if I plug in 0, 0, it's not going to work because 0 times 3 plus 0 times 2 is 0. That does not equal 8. So the answer is automatically no. Now remember, this one here, actually, if you graph it, does make a line. So it can't just be from a graph that it makes a line that means direct variation. It has to be linear like that and go through 0, 0. So for the second one, I get 2x equals 5y. I plug in 0 for both. I get 0 equals 0. That's a good sign. Now, that's not where you should stop at that point. It's good at 0, 0. What you want to look at, say, is there anything squared? Is there any weird square rooting? Is there anything else happening, or is it just x and y? That's a good indication that it's direct variation. Now, to find the constant, we have to solve for y. Now, we'll work on solving for y later on this semester and as you move into 8th grade. But if you want to get y by itself, remember you have to stop whatever's on its side and get rid of it. And so the 5, the coefficient, needs to go away. So to get rid of times 5, I would divide by 5. I divide by 5 on both sides. It's just a one-step equation. And then I get 2 over 5x equals y. That number in front, the coefficient of x, that's the constant of proportionality. That also represents the slope. Some textbooks even call it kind of the slope, and that's where it ties into some linear questions that you're going to do later. But start with 0, 0, and then see if you can get y by itself. And if the answer is yes, getting y by itself shouldn't be that tricky. If it's no, then getting y by itself takes a little bit more work and a little bit more confidence in order to find that answer. Okay, your homework is questions 1 through 5 and 28 through 31 on section 7.3. On questions 28 through 31, there's some direct variation just like what we looked at. You want to work on the idea of does it go through the origin or not, and what's the constant of proportionality. On the first group of questions, remember those definition questions, if you're struggling with them, they're probably in the key ideas pieces of the section itself. So you might have to scroll up a few pages or flip back in your actual textbook and find some of those definitions. That should help you as you're going through some of those triangle questions. Have a good day, everyone.